This is the semester review, page 3. On this page, you're going to skip problem numbers 29, number 44, and number 45. So the first problem we start with then is number 30, and we're going to use the quadratic formula for this problem. We've been dealing with the quadratic formula this past week or so, if you've watched the 4.8 video, so this should be really fresh. Alright, so we have 1 for A, 12 for B, and negative 32 for C. So using my quadratic formula, I'm going to have negative 12 plus or minus the square root of 12 squared minus 4 times 1 times negative 32. And all of that's divided by 2 times 1. So simplifying this, I have negative 12 plus or minus the square root of 144 plus 128 divided by 2. So that's negative 12 plus or minus the square root of 272 divided by 2. Now I can check to see if the square root of 272 breaks down. I'm first going to check to see if it is divisible by 4, and it is. So 4 goes into 27 6 times with 3 left over, which makes 32. 4 goes into 32 8 times. And so I don't have 272 anymore. And then I'm also going to check 68 and see if it breaks down. So it looks like 4 will also go into 68. So 4 goes into 6 once with 2 left over. So 28. 4 goes into 28 7 times. So 68 is gone. So what we have is the square root of 4, the square root of 4, and the square root of 17. So when I simplify that over here, I have negative 12 plus or minus the square root of 4 is 2. The square root of 4 is 2. So if I multiply these two 2's, that's 4. And the square root of 17 does not simplify, so it stays there. And this is all divided by 2. Now I noticed that the 12, the 4, and the 2 are all divisible by 2. So I can simplify this to become negative 6 plus or minus 2 square root 17. For problem number 31, we are factoring. These three things do not have anything in common, so I'm going to start by taking 4 and multiplying it to the 6. So I'm going to have x squared plus 11x plus 24. I'm looking for what multiplies to give me 24, that also adds to give me 11. And I could see that 8 times 3 is 24, and 8 plus 3 would be 11. So those are the factors for this part, but I have to divide by 4 because I had a 4 to begin with. So I have x plus 2, and I have x plus 3/4. The 4 and the 3 do not simplify, so I squeeze the 4 over, which makes this be 4x plus 3. And I can always double check myself by seeing if the first numbers multiply to give me the first number at the top. Does x times 4x give me 4x squared? Yes, it does. So x plus 2 times 4x plus 3 is my solution. Number 32, we're actually using the quadratic formula, 32, to solve this. So x is equal to negative b. My b is negative 16, so that's already negative. So positive 16 plus or minus the square root of negative 16 squared minus 4 times 4 times negative 20. And all of that's going to be divided by 2 times 4. So starting to simplify this, x equals 16 plus or minus the square root of 256 plus 160, nope, that's not right. 4 times 4 is 16. 16 times 20 is going to be 32 So 320 divided by 8. So that's 16 plus or minus the square root of 576 divided by 8. 576 is actually a perfect square. It's actually 24. The square root of 576 is 24. So I have x equals 16 plus or minus 24 over 8, which means I can break this into two things. X equals 16 plus 24 over 8. X equals 16 minus 24 over 8. When I simplify this, 16 plus 24 gives me 40 over 8 gives me 5. So one solution is 5. And on the other one, 16 minus 24 is negative 8 divided by 8 is negative 1. So these are my two solutions. Number 33. What are the solutions here? So first of all, I'm going to get y squared by myself. And the reason I know that's what, by itself, the reason I know that's what I'm trying to do is because there's no b term. Usually I talk about the bx term. You have ax squared plus bx plus c. In this case it's y, so we're missing the by term. So anytime you're missing the b, which is the middle term in your quadratic, you're always going to use the square root method. The square root method involves getting the squared part by itself first. So the first thing I'm going to do is add 3 to both sides, which leaves me with negative y squared equals 17. Then I'm going to divide both sides by negative 1. So y squared equals negative 17. Now the squared part is by itself, so I'm going to square root and square root. Anytime you take the square root of a square, it cancels the square. So I have plus or minus the square root of negative 17. Remember, the negative comes out as I, and the 17 does not simplify, so my solution is plus or minus I square root 17. Number 34, we're factoring again. So I'm going to first of all write this. I have 9x squared. I'm going to add 0x into the middle, minus 16. I know that I have a number in front of x squared, so I've got to take that number and multiply it to the end. So that's going to give me x squared plus 0x minus 144. Now I'm going to look for factors of 144, negative 144, that add up to 0. And I know that 144 is 12 times 12. So if I make one of them positive and one of them negative, then x plus 12 times x minus 12 these two will add up to 0, and they multiply to give me 144. So I have factored this section right here, but I have to divide by 9 because I multiplied by 9 in the beginning. Now this is actually going to simplify, so x plus 4/3 and x minus 4/3. And then in both cases, because I am factoring, I've got to squeeze. So I'm going to have 3x plus 4 times 3x minus 4. And that's my solution. And again, if I want to double check myself, if you look at the first number of each group, is 3x times 3x going to give me 9x squared? And yes, it does. So that's my check. On number 35, what's the standard form of this expression? Well, it is addition. Make sure you notice it's addition. So all we're going to do is combine like terms. 4 plus negative 3 is 1. 6i plus negative 6i is actually 0. So 1 plus 0 is 1. So in this case, this simplified to just be a normal regular number. For number 36, we're looking for the minimum or maximum value. The minimum or maximum value is always the vertex. So we're trying to find the vertex of this quadratic function. So I have x equals negative b divided by 2a. So that's going to be negative 8 divided by 2 times 2, because this is my b and this is my a. So I have 8 divided by 4, which is 2. That's the x value of my vertex. To find the y value of my vertex, I'm going to plug 2 into the original equation. That's going to give me 2 times 4 minus 16 plus 8, which is 8 minus 16 plus 8, which happens to be 0. So that's my y value. So 2, 0 is the vertex, and the vertex is the maximum or the minimum, depending on which way this graph goes. It's actually a minimum in this case, because that's positive, which means that it opens upward. For number 37, I'm going to simplify the square root of 240. So I'm going to break this down. It is divisible by 4, so I'm going to do 4 and 60. I'm going to break 60 down into 4 times 15. So what I have is the square root of 4 times the square root of 4 times the square root of 15. The square root of 4 is 2. The square root of 4 is 2. The square root of 15 does not simplify. 2 times 2 is 4. So I have 4 square root 15 as my simplified answer. Number 38, I'm going to multiply the outside numbers to get 20, and I'm going to multiply the inside numbers to get 50. And then I'm going to also see if the 50 will break down. And it does. It breaks down into 2 times 25. 25 is a perfect square. That's why I chose that number to break down. So what I have now is 20 times the square root of 2 times the square root of 25. The square root of 25 is 5 times 20 times the square root of 2. 5 times 20 is 100. Square root of 2 is my solution. Number 39, we're trying to simplify this. I'm going to break it into top and bottom first. The square root of 4 divided by the square root of 7. And the problem with this is that the square root of 7 does not need to be in the denominator. So to get rid of it, I'm going to take the square root of 4 divided by the square root of 7, and I'm going to multiply by the denominator. So the square root of 7 is my denominator, so I'll multiply by it again. And since I do it in the bottom, we have to do it in the top. So I have the square root of 4 times the square root of 7. The square root of 4 times the square root of 7 over the square root of 7 times the square root of 7, which is the square root of 49. So let's see what simplifies. The square root of 4 is 2. The square root of 7 does not simplify. The square root of 49 is 7. And that is a simplified answer. Number 40, we're trying to do the transformation and graph it and domain and range. So, transformation. This is a stretch of 4. In X world, we're going to move to the right 3 places. Outside of X world at the end, where we're all by ourselves at the end, it's going to be up 2. So when I go to graph this, I'm going to start at 0, 0. I'm going to shift right 1, 2, 3. I'm going to shift up 1, 2, and that's going to be my starting point. That's my vertex right there. Sorry for the not very good dot. Okay, this is a stretch of 4, which basically tells me my slope is 4. So I'm going to go up 1, 2, 3, 4 over 1. And I'm going to mirror that on the other side. 1, 2, 3, 4 over 1 to the other direction. And when I connect these dots, I have a nice, skinny, stretched parabola. The domain for any parabola is all real numbers. And this range y is greater than or equal to 2, because 2 is my lowest value. Number 41, we're trying to find the inverse. This goes way back to the beginning of the school year. To find the inverse of a function, you take its y and its x and you switch them. And then I want to just resolve this. So I'm going to add 5 to both sides. And then I have 2/3 y. I need to get rid of the 2/3, so I'm going to multiply by 3 over 2, because 3 over 2 is the reciprocal. So 3 halves x plus 15 halves equals y. The 3 over 2 times x gives me 3 halves x, and 3 over 2 times 5, put the 5 over 1, and you get 15 over 2. Number 42 is also an inverse problem. So x and y, we're going to switch them. Then we're going to go through the process to get y back by itself. The first thing you have to do is, basically it's the reverse of the order of operations. The first thing I'm going to do is get rid of this divided by 5. So to get rid of a number you've divided by, you multiply both sides. So 5x equals negative 3y plus 7. So now I'm going to subtract 7 and subtract 7. So 5x minus 7 equals negative 3y. And I still want y by itself, so divide by negative 3, divide by negative 3. And my solution is 5x minus 7 divided by negative 3, or you can actually put the negative just right in front of the fraction. That's the inverse. Alright, number 43, we have f of x and we have g of x. And we're going to find g of 2 and f of 2. And this is actually really simple. Here's my g of x equation. When you see g of 2, that means plug in 2. So I'm going to have, instead of having negative 1/2 times x, I'm going to have negative 1/2 times 2 plus 5, because I'm plugging in 2. And that looks funny right there. Alright, so negative 1/2 times 2 is negative 1 plus 5. Negative 1 plus 5 is 4. So g of 2 is 4. To find f of 2, I'm going to use the f equation. And instead of using x, I'm going to use 2. So I'm going to have 2 times 2 minus 3. So that is 4 minus 3. So f of 2 equals 1. So anytime you see this type of problem, you're just plugging in the number. Plug in the 2, plug in the 2. Number 46 is the last one on this page. We're going to convert this to standard form. All that means is FOIL this out and combine your like terms. So x times x is x squared. X times negative 2 is negative 2x. Negative 5 times x is negative 5x. Negative 5 times negative 2 is plus 10. Then I have a plus 10 at the end. So when I combine my like terms, I have x squared. Then I have negative 2x and negative 5x together, which is negative 7x. And then I have 10 plus 10, which is 20. So f of x equals x squared minus 7x plus 20. That's standard form.